Yo, what's up? Let's kick this off. Not feeling 100% today, but I'm gonna do my best. So we're currently researching a proper way to tessellate a mesh for it to have a good performance and a nice visual look as well. We're eventually going to use this for both, for multiple different stuff. And this is an approach that generates the normals as well on the GPU. And I'm a little bit shocked here because we ended yesterday's stream on, we had some lighting artifacts. And so instead of returning light calculations, we just output the normals, and the normals, they actually look real good. I'm wondering if it's the color scheme that or if something is wrong with the light calculations, because this looks very smooth and nice. Even with, even with low mesh resolution, we get a pretty good result, I would say. Then when we go above, oh, we can actually go down to 6. I think this looks real good. We have some silhouette problems, which will hopefully be fixed when we add the additional split on quads here. I think we're going to do, let's see here. So what I'm wondering is if we do light calculations instead of outputting the normals, we get some, on this side it looks pretty good, but on this side we have artifacts like this. You can see some of the squares here. So this side, not so good. Here, for instance, what is going on here? So if we do low quality normal calculation for a point, let's say this point, then we take this, 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 and this. So this one is a little bit darker as opposed to this one. Still not sure about these artifacts here. We're gonna try one thing. We're gonna reintroduce this stuff. We're gonna do it like this. Split flag. Would love to use this one, but instead we're gonna do okay, I get it, I get it. We want to have a level here as well. We want to put it after the sampler. We want to set it here as well. Okay. Do level, and it's this level we use. Factors edge 0 divided by 2. Really? Float 2. Can we just do... Then we can do... No, it's split quads 1. Okay. Yeah, because we also need to put this one at 0, I think. Now, okay, so what do we get here? We don't recalculate normals for these. That's pretty bad. So we get even more of a... And I would even say... I'm wondering if we even get the correct offset. I don't think so. So if we take a look at this one, let's bring it down. Yo, good morning, Geralt. Yeah, I don't know about this. Okay, actually, maybe. So this peak we get here is not related to the splitting of quads. Let's take a look. Split quads. You know what we're seeing here as well. I don't know. these wire, what is it called? Selection wire artifacts we see. We're probably just seeing this here in the background. Okay. Fuck this normal. Why don't we get a better normal result than this? And if we do, yeah, we're gonna have to add some structure here. So we're doing a lot of experimentation with level here. And step UV and step BS. Okay, we're gonna go back a few steps. I want to make sure. 1, 2, 3, 4, that our texture properly fits this quad and stuff like that. So we're gonna do, let's see. P1, we just want to do input.uv here. And it is extremely... We have some banding issues. Let's do this. Good morning, Harukanan. It almost looks a little bit green here. Fuck. Yes, and then I want to do the old rescale and offset so that each vertex gets located in the center of each color pixel, which we have done so very many times. Because I want to see if basically when we do samples here, when we go down sample levels, we want to match step world space and step UV, and we want to be in the middle of pixels until we actually have more vertices than we have data points in the texture. But yeah, let's see. One thing I want to do as well is we are gonna skip this one. So when we change tessellation power here, I also want to change the level we read from. I think, I'm pretty sure. Although I wonder. Let's see. Ooh, okay, that is true. I didn't think of that. Do we want to go with a if we subdivide once, so initially we have 4 points in each dimension. If we subdivide once, we get 7 points. 2 gives us 13 points. That's not good. If we go with 4 edges initially, then we should get 8. Okay. And let's do this. The initial number of vertices is a little bit weird. 4 edges, 5 points. Nine. Yeah, and that's why I've seen terrain textures go with a size of n to the power of 2 plus 1. I reckon. But yeah. Is there any way around it? If we have an uneven number here, it doesn't work. If we have an even number, it doesn't work. 4 becomes 7. 5 becomes 9. So in our previous terrain and snow solution, we haven't really aimed for a perfect, quote-unquote, perfect tessellation. So we haven't really cared about the n to the power of 2 plus 1. We haven't really handled it explicitly. But if you rely on subdivision, is there really no way around getting an uneven number of points per edge? I don't think so. So that would mean, let's see. One sec. That would mean that we would go not 1024, we would go 1025. And we would go none, we would go down to, what did we pick here? We went 28, 29, 129. We can also do this actually. Scale image 64, 32, 16, 17. If we go 17 times 17, we do a start. We don't split them. We do a start of, we have 1, 2, 3, 4, 5 vertices. And then if we subdivide them once, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we do it once more, we get 17. Okay. But. Yeah, then we just want to scale it a bit. We're done. Okay. I guess if we want to have subdivision like this, this would be the way to go. Hmm. Okay, let's try. So we want to scale it by... Let's see here. And we just do 1 divided by dimension times input.uv. No, depends. If we do 1770, height map size is probably what we want to go with. Height map size, yes. Really? We want to do one sec. We want to offset it as well. Offset should be 0.5 times 0 divided by height map size. Half a pixel. Scale is a bit off because I think we need to do I'm gonna go -1 here. Or actually we want to make it bigger, don't we? Resolution minus. Oh. A dot. Height map size. We do height map size. We have it at 1717. 0.5 times 1 divided by resolution subdivided. This one is correct. This one is not. I wonder if do this real quick. Take a look. The offset is correct. Now we just want to make it... want to make the UVs a little bit bigger. Bigger steps, or... bigger steps by 1 pixel. It's not entirely true. With this offset, I'm even wondering... I'm having a hard time today to make this make sense in my head. 17 pixels, 17 vertices. Place them in the middle of the pixels. Do we actually have... should be this one. Jesus, one sec. Did I fuck up? No, I didn't. Yeah. Okay. This makes us go from 0 to 1 plus something. We get clamped. And again. Want to do this? What do we have here? 1, 2, 3, 4. Hmm. And we want to scale it down. 2 times. Is that correct? No, it's not. Not here. But wow. Let's see. Terrain debug. Shader. We should be doing the exact same thing here. We do it by get terrain-based data, input UV. Size in x minus 1 divided by size x plus. What the fuck? Okay. Let's do it like this. Float to UV is equal to X, 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 Y, Y, Y. And then we have these, and we just do, depends on if we're screwing with input UV previously. We'll see. Yeah, it's not correct. 1, 2. We only get 16 colors for some damn reason. And our height map size is at 1717. Tiling 1, 1, offset 0, 0. Guess we could fuck with these instead, but do we do anything with the UV? Here we just send it onwards. UV interpolated should be okay. I hope. UV, UV. Okay, that's good. If I fuck with the UV in test quad, I divided by resolution -1. Resolution in our case is 5. So this one is 5, we go up to 4. So no, we get 4 divided by 4 at most. That's correct. So what is going on here? If we do, I just want to check if we tiling 2, 2. Oh, we don't use that one, never mind. Okay, but what if we do UV is equal to 0.5 times input.uv. And not 0.5, but 2. What do we have here? Seriously, only have 16 times 16 pixels. What the fuck am I missing? 17 times 17. Which one are we missing then? Actually, let me do sRGB apply. Does this make any sense? Thank you, Jesus. There we go, 17. So then if we go with this scaling, we get this. Okay. I wonder, can be compressed if mip maps are enabled. Okay, so we're not gonna be able to rely on compression. We should still be able to do. I wonder how MIPS will be handled when we have an non-power of 2 texture. WebGL 1 period, I don't care about that too much. Power of 2. I wonder what would happen. So here we have it like this, and we do mip map level 1. What happens then? And then we do UV is equal to 2 times input.uv. Then we get 8. Yes. So this is where it starts to break. So what the fuck to do about this if we use non-power of 2? Do we just eat the loss when we look at it from afar? Like, do we only care? So, I mean, that would mean if we go with a original texture of 17 times 17, if we move away and don't tessellate as much, we move down to 8 times 8, then 4 times 4. So it... Yo, good morning, Cooler. Because if we choose to subdivide our mesh like this, we're always going to end up with an uneven amount of vertices. I don't think there's any way around it, honestly. So you're always going to have one more vertex than you have pixels. If you want one vertex to align with one pixel, that is. Unless. One sec. What if? What if? What was the original of this one? 5 vertices. And then we do... One, two, three, four, 5. And then we do 2. 9. 3. 13. Yeah, you always get uneven. So here we split each edge into 3 edges, which means if we would start with 3 edges, yeah. I mean, what you could do is... Can we do it like this? wonder if we care that much about compression. But for instance, if we do 129, um, '29, 129. And then should do we 0? Uh, one. 129. So we go 65, 65. And then we do 2, 33, 33. Honestly, I don't care that much about the compression. I'm just wondering if... Is this half the pixel? I don't know. Then we go 3. And we do 16, 17, 17. We should have a 17 times 17 pixel. We have... Oh yeah. We should have a 17 times 17 texture. Should be able to align them in the center here, but this is a MIP mapped texture and we get a little bit of an offset. I think that's because as soon as we go down in MIPS, we lose our extra pixel pretty much. That's the bigger problem, as opposed to the compression. That we can't rely on MIPS with this. Fucking hate it. Let's see here. Can I get... Serve. Hmm. This was not a problem whatsoever before. Introducing this type of tessellation. And I guess we have two routes to take here. Either we go with n to the power of 2 plus 1 textures, but we're gonna have to implement some sort of downscaling ourselves if we want to rely on it in the shaders. Or we just skip it, but that's gonna result in extremely weird terrain popping, I think. Because it's hard to get around the fact that our terrain is always going to be 2 to the power of n plus 1 vertices. Okay. Yo, what's up, Dev Spires? Thank you for the raid, appreciate it. And Harry O, what's wrong with 2 to the power of n plus 1? I just got here. Hello. Yeah, what's up, Harry O? Yeah, we're doing some Spires, thank you. We'll try to. I've been relying on MIPS quite a lot in my shaders. I think it's a great way to get average data in a quick way. And if we go with 2 to the power n plus 1 data textures, it's my understanding right now that we can't really rely on MIPS in the same way, right? Because we're always going to have a problem generating MIPS. Yeah. Okay, I really thought we had gotten around this, but I shouldn't have celebrated too early. So as soon as we introduce tessellation like this, controlled tessellation, it reintroduces this problem. Okay, so I love the idea of 2 to the power n plus 1 data textures, except for the MIPS. I don't know what you do about the MIPS in that case. We could probably go back and change a few things, not rely on MIPS as much. Or possibly ignore the fact that we don't have a one-to-one relationship between vertices and pixels when we downsample. Or we generate the MIPS ourselves. No idea how we would do that, though. Generate MIPS. Do we have... Up to the next power of 2 size. I don't care about memory, it's just the fact that I want it to map down. So what we have here is a... let's see. We have a 129 times 129 texture. We read the MIP level of 3, so that would be 128, 64, no, 128, 64, 32, 16. Since we have +1, so 16 plus... So if we would sample this as a MIP level of 3, I would... If it was a power of 2 texture, we would get a 16 times 16 texture here, but we want to map it to a 17 times 17 grid. And that's not really what we're seeing here. We're seeing a texture that is u is equal to 2 times... We're seeing a texture that is (16 times 16). So even though we originally have a 129, 129, downsampled we get a 16 times 16. I guess I would say that we probably throw away 1 pixel, or I don't know. Okay, border, fade out to gray, bitmap limit. Because what I would like to see is that at every... Actually, if we do it like this... this is where the hard part comes in. At every subdivision resolution of this plane, I would like to see a 1-to-1 mapping to the texture. And I guess that's the main problem. If we do n to the power of 2 plus 1 textures, we get a 1-to-1 mapping on when the tessellation amount corresponds to the texture resolution. But as soon as we go down from there, we no longer have a 1-to-1 relationship. I wonder... 17 times 17. What do we have? 5, 9. 5, 9, 17. Could I guess that the next is 33? Maybe. I'm a little bit afraid of what kind of hopping we will get. Maybe that's not too bad. If we just skip... Okay, let's do this. We do n to the power of 2 plus 1. If I just try to imagine, if we don't rely on MIPS at all, let's see here. Yeah, I also wonder how the normal recalculation will behave if we do... Because if we... Can I draw this real quick? If we have... scale all of these. Guess Okay, original texture, let's see. You know. So non 2 to the power of n plus 1. When we subdivide, we get 1 here, here, and here. So we get 7 vertices. I wonder if I prefer this. I don't know. Where would be located here? We can't add. We're never gonna be able to add a subdivision amount that makes them sync, right? Do love my MIPS though. Hmm. if we subdivide this one, so like if we want MIPS, it's a question of you could either do, okay, if we go with a 1-to-1 relationship between pixels and vertices, we're gonna have to rely on 2 to the power of n plus 1 textures. Or instead of placing or if you want 2 to the power of n textures, you could go with a solution where you do something like this, which is honestly insane, I reckon. Or you place vertices at intersections between 4 pixels, but is that weird? I wonder if the normal, and then if we calculate the normal, we take this. So the center of them. Is this weird? Hey, what's up, GDs? Okay, what we're looking at here are the grids are textures, the circles are vertices. I'm trying to finally settle. Like, so previously, when it comes to our terrain and water and snow and whatnot, we haven't really cared about how it tessellates. We have just cared about that it tessellates. So when we do our texture to vertex relationship, for these things, we've always just set them at one vertex at the center of a texture pixels, and we let the texture decide the size. So if we have an underlying texture of 128 times 128, we have always decided to have x minus 1, y minus 1 vertices, so 127 times 127 vertices. I guess the standard, what you usually do is you go textures that is 1 pixel bigger, but then you can't rely on MIPS, which I like to rely on. So I'm wondering what the pros and cons are to do something like this, which instead of placing vertices in the center of pixels, we place them here. So it's actually like if the texture was downsampled one time already, but with overlapping pixels. I don't know if this is preferable. The good thing is that we can rely on MIPS, auto-generated MIPS. What is actually... So I guess... Fuck it, let's take this one. It's a question of... this versus this. Both... not really. 1 sec. 1, 2, 3, 4, 5, 6, 7, 8. Not really, not really, not really. I reckon it's the difference, it's the choice between these two solutions. We always want to be able to if we subdivide this one, we get new vertices on empty pixels. If we subdivide this one, we get empty pixels here. I guess this would lead to a little bit of a smoother result. So it's these two options against each other. The positive thing with this one is that we can use MIPS. We can't with this. I don't even know if you would render a terrain with this setup, but not fully subdivided. So you have points like this. Worst case scenario, you have a peak here. You have a peak here. You have a peak here. You have a... So high value, low value. So instead what you're gonna get is you're gonna get high value all over these, and then the closer we get, the more this one decreases. You could probably do something similar here, couldn't you? Okay, I like to do stupid stuff and eventually find out why nobody does said stupid thing. So I wonder if I just want to throw something together real quick using this and see what we get when we downsample and displace. And look at it like a learning experience. Like, I wonder why this is standard as opposed to this. And that's what I want to find out. Wonder how this will eventually work with fuck it. Let's try it. So we want to do a little bit of a different scaling here. First of all, I want to go with let's open up 128. One 1616. Go 16 times 16. We'll remove this. And I also want to go, let's do 0 here. Sixteen times 16, we don't want to do this scale anymore. So what if we don't scale it at all? Then we just get input.uv is equal to input.uv. Then we get this, but what we would like to see... so we would like to see... we want to scale it by... two pixel lengths, I suppose. 16, 16. And we want to offset it by 1 pixel length, so 0 is here. And then we want to scale it. We can start by offsetting it. So let's see here. Float to, let's do it like this. Let's just begin with the offset. The offset is this, I reckon. So now our 0 is here. We have this problem. Our 0 is here, that's good. I'm gonna make it a little bit bigger. Yo, what's up, Derek? Long time no see. I wondered what was up. Just got back from vacation. Nice. Sounds good. I hope you had a beautiful vacation. Catch me up to speed. I don't think there's much to catch up on, actually. So last week, I only streamed 2 sessions, I think. Cause of some renovation and sickness. But in short, we are trying to... So I said it previously, and I think that pretty much sums it up. So let me repeat. Previously, when we have tessellated our terrain, water, and snow, etc., we haven't really cared about how it tessellates, just that it tessellates. So right now we're going down a route where we try to control the tessellation a bit more. So we try to make it tessellate in power of 2s. So 18 vertices should be 16 vertices or something like that. And by constraining the tessellation, we have noticed that we distort the relationship between vertices and data points. So previously, if we have a 16 times 16 texture, we have always gone with an initial mesh that has 16 times 16 vertices, right? But if we want to rely on a more constrained tessellation type, but the problem is, like, I think this one explains it the most. So this is what we have relied on previously. We have a texture that is 4x4. We have always created a mesh that is 4x4 vertices, and then we place the vertices in the middle of the texture pixels, pretty much. But now when we have constrained the tessellation, that means that tessellating this once will give us something like this. So we will start distorting that relationship. We no longer have a one-to-one pixel vertex relationship. And the way, or the most popular way to do it, is to have, because you're always going to get a problem with this tessellation, that you have an initial mesh of 4x4 vertices will always tessellate to 7x7 or 13x13, I think. We get an uneven amount of vertices. So a go-to solution for this is to always have, when you have height maps for terrains, you have height maps that are 2 to the power of n plus 1 in pixel size. So this one, for instance, is 9x9 pixels. So if we start with 3x3 vertices and start to subdivide, we get 5. And then when we subdivide again, we fill out every pixel. So that's a nice relationship, right? The only problem with this one is that you have textures that are 2 to the power of n plus 1, which disables compression, which I don't really care that much about. But you're also going to have a problem utilizing MIPS in a way we have, because you can't, when you downsample a 2 to the power of n plus 1 texture, you get this wonky result, right? So we were just about to try and dive into this, which we will probably end up, or I will probably end up understanding why this is not something we do, and why this is standard. But I want to find it out, because in my mind, doing it like this would work. So instead of having a relationship between texture and mesh that is each vertex of the mesh is in the center of a pixel in the texture, we do each vertex in the mesh is in the center of 4 pixels in the texture. But I don't know. It's a mess. It's a mess. Yo, what's up, PG King? Good morning, good morning. Does this work? If we subdivide, we get here, here, here. Yeah. So what have we done here? We have offsetted this 1 pixel. Now we just want to scale it. Do we want to scale it? We want to make it, I wonder if we just want to scale it by if we just want to scale it by +1 here instead. No. Really? am I... Okay, so let's do this actually. Test quad. Let's go with 4 initial. One, two, three, 4. And what kind of texture do we have? 16 times 16. Let's actually do a 1, 2, 3, 4. 7. Create one that is 8 times 8 as well. And use this one. 8 times 8. 8, 8. Can we do sRGB? I don't want to return it as sRGB. What did we have? Reflection. And we have something right here. sRGB to linear. But it's not, so I wonder if we can do linear to sRGB. I'm just wondering why I'm not seeing a difference here, or it's very hard to see the difference. While maybe... Okay, let's do this then. Is there actually... It's these. Okay, let's keep it like this. Let's do... What the hell? I mean, this is gonna make it harder to calculate or see what we're actually doing, but okay. What do we have? 4 vertices, we want to place them at... We want to place it here, 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 and here. We want to offset by 1 pixel. This is the 8 times 8. So the offset we want is this, right? Then the scale is probably going to be... Let's take a look at what we get. We're positioned here. Is that true? It's impossible to see with this. Yeah, we're positioned here, right? Or here. Here. So we get these 3, yes. And then we're positioned roughly around here. We need to scale it. We need to make it smaller. But I wonder if we want to do... Question is how much smaller? We want to move... We offset it. So we want to go from... Do we want to skip 2? Hard to see. This one is correct at least. We're here. We have 3 of these, and then yes. This one is, we should be having possible to see. This one. I think it's correct. These gets rendered at this, as the same color here. Derek, are you worried at all about the effect of the averaging with it aligned that way? That's a good point. It's pretty much, yeah, we get a lot of smoothing with this. We actually, so if we have a max texture of 128 times 128, we actually only have 64 times 64, right? And yeah, we would have problems getting to a max pixel, definitely. That is one of, if not the biggest drawbacks by doing it like this. That is definitely true. But like, I'm wondering if we can use it to our advantage when it comes to gameplay. So when we do a lot of terraforming is it preferable to have this smoothing effect on the terrain or not? Maybe I'm a bit too optimistic. Okay, but this looks to be all right. So then if we tessellate this one once more, we get these here. If we tessellate it more, we get in the middle here. So if we had a greater texture, it would be aligned. 3, 4, 5. This looks pretty good. So yeah, like, I still think, apart from what you mentioned, Derek, we're probably, like, I'm fully ready for when we run into something that makes this unusable and tells us why this is the way to go. Maybe I'm a bit short-sighted, but yeah. So if we go with, let's do 0 here again. If we up this texture to 16 times 16, 16 times 16, this one, we end up here. Actually, then we need to change this one to 16 times 16. This time around, because my idea here then is that we're gonna sync what MIP level we use with the number of what MIP level we use together with what tessellation we use when we calculate height. So in this case, since we only have 4 vertices, we would use this texture. So we just downsample. But then if we go up to this one, we don't have any answer for, right? 8 times 8. Do we? No. But this one, $13. The idea then would be to go to this one, 16 times 16. Maybe there's something in between the two solutions, but doesn't the regular tessellation generate vertices at those average position? So the idea is that when we tessellate this one, we will get this. So it's pretty much like if we have, let's see, okay, I see. 1. What I want to make is I wonder if I can, if we're able to sync this all the way through. But not like this. 2. Yeah, we need. Yeah, so if we go, okay. If we subdivide with, oops. So something like this, right? And this is what we originally have. Then we subdivide once, or... But yeah, here we add 2 points, here we just add 1 point. Yeah, so the idea is that we're gonna, if we tessellate, like we're gonna sync the tessellation amount and the MIP level amount. So the more we tessellate, the more we move up in the MIP level. If that would be possible. Let's see here. So it would be... Wonder. Something like this. So let's see here. If we have... If we have this mesh, and in this case we tessellate each edge once more, so we get this. Right. So at this MIP level, we calculate what 1 pixel is, and we offset it in with that. Here we have a one higher, we're gonna have to jump over 2. Something like this is what I want to achieve. I'm feeling pretty optimistic about it right now, but we can also see here that we will get a shit ton of waste, right? But we will get a lot of waste here. I wonder... There's always a problem with seams. So for instance, if we go to a solution that only calculates the normals, right now we calculate the normal on the CPU, because of the seam problem. If we were to calculate the normal for this vertex on the or if we go to this old solution, if we were to calculate the normal of this point with this setup, we wouldn't be able to do it on the GPU unless we send in the next patch and the next patch. Unless we send in 3 other height maps, so the neighboring patches. With this solution, we would get so much waste. We'll probably get like pixel values here which aren't used, but that can also be synced with neighboring patches. So when we can, I don't know. 2 backsides so far. Damn, I really need to do a summary after this stream to keep track of everything. But I still wanna feel this one out. But the problem is, okay, let's see here. So we start with this. We want to start with, actually right here as well, we would get, I forgot, we would get these vertices as well, right? Yeah, we would. So we always want to start with, how can we do this? Okay, let's say that our maximum texture is 16 times 16. Then we have 8 times 8. This is 16 times 16, scale image 8 times 8. And then scale image 4 times 4. So let's say this one. So we have 16 times 16, that's our 0 MIP. 8 times 8 is our 1, 4 times 4 is our 0. So we want to go, I guess we want to create the initial mesh in such a way that it's the size of this one minus 1. So let's jump to the quad here and we do, that's quad, we do 3 here. Then we do, okay, so now we have 3, we have a 4 times 4, 4, 4. So we're located here, 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 and here. Hard to see with the sRGB, but I'm pretty sure. Let's do it like this. I mention here include scale and offset. And then we do float to UV is equal to input.uv. If we get on 0.5, so here we have the original texture. If we do include scale and offset, we get this. So at this point, I wouldn't say that we lose, what is it, 12 pixels of data. It's just that we average them. Oh well. Okay, so then if we go up to 8 times 8, we want to subdivide this one once enough. 2 times once. Should be okay. So here we have original texture. So now we have 8 times 8, and if we include it, it looks like what am I missing in this conversion here? Oh yeah, because here we actually want to do, still want to do 4 times 4 here. We still want to do it as, okay, it's, okay. We still want to jump scale 4 times. Does this look all right? So now we have this one, but we pretty much only use this one. I think that's about right. So look at this. This is what I'm a little bit worried about. Or we're pretty much basically just using these. So we lose 8, 16, 12, 28 pixel values that are not used at all at this point. And it's only gonna get worse. If we subdivide once more, we want to go up to 16 times 16. And we get even more waste. But so when you do, I don't know, this varies between hardware, I guess, but if you have non-POT textures, non-power of 2 textures, and you generate MIPS from them, I think, or you want to try and compress them, you're gonna go to the next level of POT. So you're gonna get a lot of waste either way. But still. 16 times 16, we actually only use so let's do it like this. 16 times 16, 256, yeah. 256, and what we're using is, we're always going to use 8, 9, 9 times 9, oops, 9 times 9, 80. Seriously? That is a lot of waste. What did we have? Previously we had a 8 times 8, 64. So and we use, actually I might have, we actually use one more on either side. So here 4, 5, 6, 6 times 6, 36. And on this one, 2, we actually use 100 here, but that's insane. $39. Oh. But I wonder, if we can keep the waste constant. Yeah. Mm. But I removed the wrong. Oops. No, I didn't. Fuck. Mm-hmm. I guess we're gonna have to go. Is there no way around the waist? Do we always get a mismatch in points? Maybe. Unless we add. I wonder here, we could, if we remove every other, we go to, then we get 4. Mm. 3, 5. I'm trying to figure out if we tessellate this less, we remove half the points, but then we can't really. Let's see here. If we tessellate, Okay, let's say that we start with 3 points. Then we're gonna get 5 points. Right. And then we're gonna get plus 4, 9. We're gonna get 17. Then we're gonna get 33, right? Then we're gonna get 55. No. 60, 65. Eight, 16, 32, 64. Right? It's always going to be one more. 128, 127. We should be able to sync this with a texture that goes like this. Shouldn't we? We'll find out. This should be 129. Or actually, it's like this. One, 2, 3, 4, 5, 6, 7. 4 times 4, 8 times 8. Yeah, okay. So what we would like to have is... Then we're gonna get... Still gonna have these. Like, if we want to minimize... What am I missing here? 1, 2, 3... Okay, let's do it the other way around. What do we have? 4 times 4. If we force... the fuck? Yeah, we're gonna get an offset. I don't think we can keep the middle of pixel relationship, or the intersection between pixel relationship without having this much garbage. We're gonna get eventually. So if we would base it on the texture with the biggest resolution, or our most detailed texture, if we subdivide it from there, we're gonna get in the middle of the pixels. Is that true? But, one sec. Maybe. We can do it with a simpler. So, initially, if we subdivide this one once, we get this result for we sync the number of vertices to the finest texture resolution we have. And then when we go down one MIP level and one tessellation, we get something like this. So now we're in the middle of the pixels, and there's really nothing we can do about it. But 7.5, we should, yeah, in this case we should get 5. Yeah. Right. 7. 3, 5. Okay. We don't really have a... Wonder if my relationship is wrong from the beginning. 3, 5, 9. We'll never get 7. A mess this is. But it's true that we always want n minus 1. No. Okay, if we go the other way around, let's say 8 times 8 is our biggest. We have 7 times 7. We're going down to 4 times 4, then we should get 3 times 3. Mm-hmm. 3, 5, 9. No. We're always gonna have to... this one. So my question is... Can we make this... Can we make them sync all the way down? Without having so many empty... So I don't know. then again, what the fuck? If we want to get good normals, I guess we would like to sync it. But. Yes, we can do. So if we go with 16 times 16, so 3, we don't include this one. Then we do 16, 16, we include it. What am I missing here? Sixteen times 16, we want to move 1 divided by 16 in x and y, which we do here. 1 divided by 16, and then we want to scale it. What the fuck do we want to scale it by? do we have? We have 16 pixels. £17 points. Don't we want to? We want to scale it by 16 divided by 17. No, we want to make it bigger. No, we want to make it smaller. I don't know. No, we want to make it smaller. 16 divided by 17. Don't we? One should be equal to 0.9 something. Which is why we have a 16 times 16 texture. We wanna remove 2 of the pixels. Which is why I wonder why this one isn't giving the correct result. We're getting the correct result, but we don't align it. Is that true? Hmm. Yeah, of course. Yeah, unless we have a lot of rubbish. Yes. Okay, I get it. I get it. We always need... Yeah, we're always gonna try and align 16 with one below. Maybe. So that would be if we have a 32 times 32 or 128 times 128. Yeah, we're gonna get a lot of unused height values with this approach. Which sucks. Let's see here. If we start with 2 vertices, subdivide it once, we get 3. Then we subdivide it once more, we get 5. Then we subdivide it once more, we get 9, right? And then we get 17. And we continue like that. So we get 33, 65. No matter what if we start with 3, we get 5. Okay. So it's just a matter of where we start. We always need our texture to have more data available than this. So for 2, that would be 4. 3, that would be 8. 16. Then 32. 64. 128. And that's when we get this ratio, which is 65 divided by 128. I guess it's only going to get worse and worse. Or is this the ratio we're going to have? 3. We're going to get 27. This is n to the power of 2 plus 1. Yeah, we're always going to have half of the texture. not used. If we want to sync with this, yeah, that's rough. That is extremely rough. Although I wonder, quad. Unless we go with five, 6, 7, 8. Then we don't have. Then we lose the nice subdivision. So now we have moving vertices. Sucks. Guess we go 2. Let's see, if we have 18 times 18, can we get 7? 1, 2, 3, 4, 5, 6, 7. But then we can go with 7. So then we can stay 1 below. 16, can we go with 15? $17. 15. So we could always stay 1, but then we would get moving vertices, and that sucks. So it would pretty much only be Would probably work for snow, but I don't see it working with terrain really. But I reckon we could just scale this one differently. Maybe we could come up with some magic here. So I'm gonna have to analyze the empty pixels we get here, because I wonder if we could 256. Well, let's see here. Okay, I think it's pretty apparent why this one is preferable. Still wonder if there's any way around this waste we're seeing here. Yeah, like around 50% of a texture not being used. Not a big fan of that. When I think about this, it's not only... So if we were only working with a height map, I could go with a height map only being 2 to the power of n plus 1 and work around that. We just don't need to use the MIP maps for height. But we have so much terrain data, some of which we want to do mean value of. Thinking about the water data and the activity data. And instead of doing kernels in shaders, relying on the MIPS is extremely useful. I'm gonna do some theorizing tomorrow as well, but right now this one is winning by a big margin. Then we will just need to figure out how to handle MIPS with this one, if we possibly don't even care about the MIPS. But, and when I say don't care about the MIPS, I mean we might not care about the extra row and column we lose when we go down in MIP levels. And this was not the problem I thought I was gonna focus on today's stream, but yeah. I have to run. We'll continue this tomorrow. Hopefully reach some conclusion at least. Yeah, have a great rest of the day. Peace.